Welcome back to Differential Calculus. I'm your tutor Ryan. This is part 6 of basic derivatives. We are covering exponential functions, and we are doing questions 6 and 7 in this video. So let's get started. Problem 6. Find the derivative of y equals e to the exponent sine x. We know the derivative of an exponential is a to the exponent x multiplied by ln of a multiplied by the derivative of whatever the exponent is. So let's solve it. We know that a is equal to e. We know that ln of e is equal to 1. And the derivative of what's in the exponent is a derivative of sine. And the derivative of sine is cos. So put it all together and we get y prime is equal to e to the x multiplied by cos of x. Alright, let's move on to problem number 7. Problem 7. Find the derivative of y equals ln of 3x all divided by e to the 4x plus 2. Alright, so there's a problem here. There's a dividing sign here. So we need to learn the quotient rule. And here's what the quotient rule states. If f of x and g of x are differentiable functions, then the derivative with respect to x of f of x divided by g of x is equal to the first derivative of the function f of x multiplied by g of x as it is, minus the derivative of g of x multiplied by f of x as it is, all divided by the square of g of x. Might need to say that a few times in your head, and here's how I do it. If f of x is the first function and g of x is the second question in the order that they come, then the derivative of the first multiplied by the second minus the derivative of the second times the first, all divided by the second squared, is the quotient rule. So maybe that'll help you remember it so you don't have to write it down, or maybe it'll just be a quicker way of you memorizing it. So alright, let's use this now along with something else I'm going to teach you in order to solve problem 7. Alrighty, let us move the quotient rule off to the side there. And let me tell you something about deriving a ln function. You'll learn it later in the derivation of logarithmic functions portion. But the derivative of ln of x is equal to 1 over whatever x is multiplied by the derivative of whatever x is. So keep that in mind for the solving of this problem. Alright, so looking at the quotient rule, we need an f prime of x and a g prime of x. That's really all we need in order to use the quotient rule in order to solve problem 7. So, what is f prime of x? F prime of x is the derivative of f of x, which is the top part of the function. That's ln of 3x. So the derivative of a ln function is 1 over what's in the bar, the brackets, and that's 3x. So 1 over 3x. And now we take the derivative of what's in the brackets and multiply it. That's 3. So we get 1 over 3x multiplied by 3. Later on, that'll turn into just 1 over x, because the 3's cancel out. Now, what is g prime of x? G prime of x is the derivative of what's on the bottom. The derivative of an exponential function plus a constant. Well, the constant's going to go away, because the derivative of a constant is 0, and the derivative of the exponential function is the function itself multiplied by ln of the base, which is e, and that's equal to 1, multiplied by the derivative of the exponent. So the derivative of 4x is equal to 4. Thus, the derivative of g of x is 4e to the exponent 4x. So we have everything we need. G of x, f of x, and g of x squared are basically already given to us. So we're going to plug that in to the equation. And it reads, y prime is equal to 1 over x multiplied by g of x minus 4e to the 4x multiplied by f of x, all divided by g of x squared. And I really don't like to FOIL out the g of x squared because it looks nice as it is, and there's no point cluttering up the bottom there. But one more thing, we have to, well, we don't have to, but I'm going to, we're going to simplify it a little bit by multiplying through top and bottom by x. So that'll clear out the 1 over x fraction on the top, and that'll multiply an x by the 4 in the second part of the top, and multiply an x into the bottom, and in my opinion it looks much nicer. So we have our answer. This concludes the basic derivation of exponentials portion of this video series. Next coming up is basic derivation of logarithmic functions, so stay tuned to that. If you wouldn't mind, please comment on the video, give any sort of feedback, whether positive or negative. If you'd like the video, favorite it. All of it really helps, and it's always much appreciated. So that concludes the video. Thanks.